start another one now, which will be for storage basically. Then we have it separate, unless you guys are going to watch a 3-hour recording at any stage. All right, so I'm just doing that now. Okay, so when we look at it too, you have to understand that data is very important. And also we're going to look at where data is stored, and key storage technologies that you use in cloud computing. We're doing the basics of cloud computing. Okay, so we've covered previously, we looked at, RAID. We'll go a bit detail into RAID here. We'll go into detail to show you what is Huawei's RAID 2.0 block virtualization technology, which mainly deal with SSDs. And then we'll look at distinguishing between centralized and distributed storage. And then also understanding your storage protocols and application scenarios. So this whole course today, or this part, will be more about understanding really how you use storage. Because normally we would just store everything onto our drive and think that everything is fine, but you need to consider a server has many use cases, and so it needs to store information separately from the server. So we're going to look at the definition of storage, the history of storage, different disk types, different networking types, and lastly the storage forms that you get, and then key storage technologies. So what Huawei normally defines as storage is, it's called narrow sense and broad sense. And all it tells you is that narrow sense is where you store your drives, your hard drive, your solid state drives, your USB drive. That is narrow sense, which means it's close to you. And when you look at broad sense like broadband and all that, you think it's further away. So yes, you would have a NAS storage, which we'll go into, which is a network attached storage, and you would have a storage area network, which is then also away from your server. And this is basically how your data centers operate. They have these big broad sense storage networks that allows your data to be stored separately. So if something happens on the server's okay, it can fail, but your storage is saved somewhere else, right? And that's basically the whole approach of calling it distributed systems. So looking at the history of storage, storage started in the 1950s, gone through different phases. Obviously, the mainframe, as you can see here, started off with the mainframe as, I think they had one big disk, floppy disk, which was the size of 5 megabits. That was a storage space. But if you look at platters, it's basically 50 24-inch platters altogether. That's the size of that. So it was quite big, right? But it only stored 5 megabits of data. And so that's how information has exploded, because you obviously have terabytes, petabytes, trillion bytes also now already. And so again, when you look at 1980s, that's where we had external storage step in. And so in the 1980s, we have something called SANs that stepped in. And SANs, as I said, is storage. Just need to check the terminology here before I say storage area networks, right? So remember, in networking, you deal with WANs, which is called wide area networks, the A for area. And so in storage, we have SANs, which is storage area networks. So that's basically what you see here. That's a SAN kind of storage server. It's not really a server, but it's used for external storage. So this drives that's in there, it's used to store external data. Then you have your normal storage network, which again here you can see there's your controller with all your drives connecting to what looks like switches here, and then that switches then connects to the servers. So that's the service there. And now we have distributed storage, where you have cloud storage, where everything is distributed and not connected just to one. Like in this case here, we have 3 servers here. If one of the servers go down, yes, your data is still there, but not really that you worry about that. It's more about your data that sits here. Your data sits here at this, underneath this controller behind this. And so this is basically your storage area network that you see here. So this is your SAN, in a way, but it could be differently designed also. So looking at the storage development side of the server side attached storage and independent storage systems, We can now look at this example here, where you have a disk in a server. So what it means that you have your monolithic approach. You have one server, you have your CPU there, and you have your RAM, and you have one disk. What this means is that if this PC goes down, you have problems, right? So you have obviously system performance bottlenecks that you'll experience. If one of these of the disk starts running slowly and running out of capacity, your reliability of your data will be lowered, and also your space utilization will be low also, because your data is then less scattered over this particular disk, and wherever you store it. So that's basically a disk in a server. When you look at external disk arrays, so here we're talking about our SCSI card, and this is obviously our controller card. You have your CPU, RAM, and your disk. And you have also a SCSI card controller that connects to other bunch of disk. Yeah, just a bunch of disk. And so what they allow you to do is you could connect all these disks together to have extended storage, in a way. But they connected to your PC or your server, sorry, through a SCSI card. So without the SCSI card, they are not connected. All right. So problem that we solved from the previous step here, because we're going like this way. So the problem that we solved is we basically looked at the number of slots that was limited, and we basically obviously increased the capacity by obviously adding all these bunch of disks. But now we have something called intelligent disk array, where you kind of have a controller that obviously does the RAID function and it does all of that for you. And but what it solved only was to solve the bottleneck. It solved the number of disk slots that was limited, and it also when the data was stored to a single disk, it obviously solved the problem of low data reliability. But we all know the controller card here is external, and again, we saw the benefits of it and the not benefits of it. So it all depends on how you think about using the controller card. Again, this is just ways of how you would use storage on your server network. Now, when we look at, call it separation from convergence. So we want to basically, do a kind of setup where you have all your storage devices all working in a distributed setup. And so what we mean by that is that you have your SAN here, your storage area network, you have your server here, and a file system. So that's a file system currently attached to the server. But then on the network, if you have your network, you have your storage area network, and that then is obviously maybe a bunch of switches and routers all connected to the storage side here. So the storage here that's sitting somewhere else is then connected via the SAN to the server in order to store information there. And then when you have your NAS again has the same features as your SAN. However, your NAS, as you can see, is not a SAN, it's a LAN. So what it means that you have your local area network, your own network that you are to create this particular file system called a NAS. And so what it allows you to do is take that storage server that you have and mount it, as storage for your server. So your server can store via the network to that NAS. And I'll maybe see if I can show you basically an example of what a NAS looks like. But I think that's basically what I want to show you with regards to a NAS. And then if you look at unified storage, which is now this approach here, you have both working together. You have your server here, you have two servers, in this case server 1 and server 2. You have your network here, and this is a switch. So you have your switch here. The switch then connects to the clients, which is the PCs here, and then the clients then connects via the switch through the network, through the file system. So it might want to access files on the file system for storage. And then additional storage, if you need additional storage, you would then connect that file system to a SAN, and then the SAN will then obviously also have additional storage. But what happens is that the switch have connection separately to the file system. So if the PC needs information, it will go via this to the file system. And if the PC needs information from SAN, it will obviously go via this, depending on how you set it up. But so that you don't have information clashing when you obviously store information. Okay, so then you have scale out storage. Now, what it means by that is that you can now scale out your storage. So when you look at earlier, we had examples of two PCs or two servers. Here we have 4 services, right? And so it means that you can basically scale out. So what it means by scale out is that you can store loads on different networks wherever you want it to be, depending on how you configure it. So if your front end service network here, where you have your data stored, all full service, and then you would have a management network also where they are connected. So this is where I spoke to you about the NICs. Remember I told you about you have one NIC, you have another NIC, you have another NIC, you have another NIC, and you can split them. One would be for management, and one would be for service or for the for the network. And so that's basically what you can do when you look at this kind of setup, scale out storage. But it's only if you need it that way. And so again, when you look at storage virtualization, this is the part where you virtualize your physical resources into virtual resources, which is the logical resource that you see here. And so again, what it allows you to do is take that physical drives, use virtualization, make them all one logical unit, although they're separate, and then that provides storage to the either management or the clients or services that use your service. And so then that is really where we talk about different storage technologies. Now we obviously have the cloud, and the cloud again uses the same concept. However, it basically combines multiple storage devices and application services together. Obviously, the cloud sits on a highly virtualized multi-tenant infrastructure, and so it has different tenants per service that it provides, and those are ways of how the cloud operates. So you have obviously maybe you have a legacy application, you have a new application. Depending on that, the cloud storage will look at that and see obviously is the complete application is fit for a particular network. But again, with legacy and new applications, you have your protocols that you need to understand that works with. And so with your protocols, again, you have either three storage. You have block storage, and that's for volumes and disks, and this is the file storage for files and any type of file. And then you have object storage, which is normally called lightweight storage that you would store information to. And those are basically different ways of how you would store information, and also looking at the elastic converts open kind of setup, which shows you how cloud stores information. So again, let's look at mainstream disk types. So mainstream disk types, we've covered that previously. We've gone through it. But now when we look at it in detail, these are the key indicators that you have to look out for. Your disk capacity. Now we saw that with regards to disk capacity, this one will give us 4 TB. That one will give us 3. So these two are for me the highest with disk capacity, right? So we could say that. And then you need to think of the rotational speed. If you have a hard disk, right? I think I'm not going to skip because it actually shows it here on the right hand side. So if you have a hard disk, you have to consider the rotational speed, the RPMs, and that also puts you into a different price bracket. Then you have to think about the average access time, how often was the drive used, the data transfer rate, and also input-output operations per second, or the IOPS. These are very important because this determines what type of drive you will buy at the end of the day for long-term, total cost of ownership, right? And then, yeah, so this is just a graph to show you how the IOPS work. If it's a higher IOPS and better performance, it means the drive will last much longer than a normal, drive with a spindle, like the on rotational speed. All right, so those are mainstream disk types. Now we look at storage technology types. So this is just showing you in a nutshell, basically how you would connect the controller, right? In a kind of three-way clusters, because that's a PEC, another PEC, and another PEC. And so what you see here, it's called DAS. In Huawei's terms, they call it DAS, which is direct attached storage. And so what it allows you to do is it's connect your server through a SCSI controller to your blocks, to your logical units or your physical servers, storage disks that's here. And so that again is how this whole thing direct attached storage work, or DAS. You can have different connectors from this again, either via SCSI, so you can use the SCSI cable, you can use fiber channel, or you can use SAS, right? Those are connection modes, how you can connect to the particular network where the controller is. And then obviously one other thing is that you need to consider the link rates. So do you need 12 gigabit speed, the link rate, or do you need more? You then configure the NICs to do it that way. Right, and then again, when you look at the introduction to the NAS, so the network attached storage, again, what it is there for is to have additional storage for you available. And so it's configured in a way in that you would use Unix on a Unix or a Linux machine and mount it via either NFS or I think the other term is SMB, by SMB. And then or you could configure via this particular file system here for Windows. And again, you would have a dedicated IP storage network. So these would be configured as spine and leaf, depending on if you do the network properly. And then you would then have your file system right and you then connected to. So again, those are basically just showing you how you would look at setting up a network topology for considering all these services in a way. Right, so now we're going to look at introduction to NAS. So what is NAS, right? NAS is the way of how you would store information on your local area network. It's supposed to allow you to have more than 30 connections, depending on how many clients connect to your network. And also it's independent of data because you store on the NAS what you want to store on the NAS. You could store even your operating system disk if you run VMware or so. You can store it on the NAS and still it will talk back to your server to run it. So that's kind of the seamless availability it provides. And so you can see here you have your Ethernet port, you have your two Ethernet ports here, or two NICs. So in this case, two is configured to use the NAS. And then you have on top of that, on the NAS, you have your file system, and then how these volumes are managed, the nodes. And so from that, you would then obviously use all of them as part of your NAS. This is your NAS whole system. So user would store information there, or there, not knowing that it's all together. So whatever you store on any disk, it doesn't matter because they have this whole RAID setup that allows that they're always available to use. So that's basically your NAS in a way. If you look at your SAN, SAN is a storage area network, and as I said so earlier with your SAN, you would have your storage devices sitting here outside your server environment, which sits here. And so what it allows you to do is use either fiber channel to a fiber channel switch to connect to the to the server, and then via Ethernet switch, which could be either LAN, local area networks, and then that you would configure, your switch again to connect to your Fusion Compute, and then the Fusion Compute then would connect from the switch to the servers. And so that is how your SAN would operate. And so again, when you look at looking at introduction to FCSAN, which is the fiber SAN, you can see that you have a fiber channel link, right? Not a network cable link, a normal fiber channel link, but you have also this whole spine and leaf approach here, similarly to basically tell the network that you need to have another layer before it reaches to the servers in this case. And then you have your IP SAN, which is now, so you have fiber SAN, fiber storage area networks, and then you have IP storage area networks. And this again uses the network cable and not now a switch. I'm sorry, not now a Huawei cable. You would use the network cable here as the link to your Ethernet switch, which then connects to your particular, maybe something you need to upload, and then that then connects then to your service in that sense. All right, so here again you have a comparison between storage and network types. I think before I go to that, let's take another 15-minute break. It's now 10:56, so we'll start 11:10 again. And then, yeah, because I think this was about 20 minutes that I talked, if I'm not mistaken. But let's take our 15-minute break again, and then we can go to the comparison part, so that at least now you know at least more about different storage. And then we continue after that with the different types, and then hopefully maybe then you understand that better also from a practical side. I'll see if I can show you practical also, this what it looks like on the server side in that sense. Right, so we're gonna take our 15-minute break and we start again. Okay, it's not 15-minute breaks already, 10:57. So yeah, but we'll start 10:10 again. 11:10, sorry. 10 past 11 a.m. we'll start again. And then we'll continue with this. Right. Thank you. All right, we're back. Okay, so we did we pause earlier. All right, so let's look at the comparison between the storage network types, and then we see basically how we can compare them going forward. So as I mentioned earlier, we have the DAS, your direct attached storage. You have your NAS, which deals with IP, so that's on your LAN, your local area network. And then you have your SAN, which is like almost like your wide area network. So that would be your WAN. And that obviously have two types, and you have your fiber SAN and you have your IP SAN. So those are the two types of storage network technology types. Your NAS only comes with IP, so you have an IP that you have that you can connect to, and that will be normally for file service, and it's very easy to install and has low performance, and obviously you can use it um, to store information to it. You also have your fiber SAN. Your fiber SAN again is using fiber channel. It's more for block level, so it's more for block level storage, whereas your NAS is more for file level storage. And then database application would use this type of storage. If you have a MySQL, not a MySQL, if you have a SQL database or an Oracle database, you would then use this particular storage channel for your storage database. It's highly scalable, performance, and also highly available. But obviously, the disadvantage is there's a complex configuration that's involved there, and also poor network compatibility, which means that you have to think of the network being just fiber, right? So if there's fiber everywhere, you need to make sure that your network accommodates with it, otherwise, you would have that problem. Your IP SAN, it just deals with IP addresses. It's also for block level storage. You would use IP SAN for video security. So if you have a CCTV or surveillance, you would use that particular storage for that scenario. So you would store all your videos, footages, recordings on that particular storage setup. And because obviously there's a strong scalability, also low cost because it's using IP and not fiber. But you have a low performance. That's why you would use video, because you don't want to have real time or faster performance. You don't need so much performance, but again, it's on the type of use case you want to use it for. So those are common ways of how you can look at storage types. Your LAN, as I said, yeah, your NAS file server. So you would store your maybe your VM disks. So it's called normally your DK, and you would store those type of files there. You could store any type of file you want to store there, even ISOs. You store all of that files there, disk images, all of that can be stored to the NAS. Okay, so that's basically the different types of storage type when you look at a comparison between all of them. So moving on, we then obviously have different storage forms. So those are storage types. The storage forms again is looking at how you would now look at your whole topology of how you would store your information on your network. So you would have either centralized storage where you store everything into one storage system, but you have multiple devices that connects to that. So you would have your server, you would have an Ethernet switch, you would have an IP link, and you would have your SCSI controller, and then your disk storage. Those are your different links and components that you would have, but they will all be seen as a centralized storage system because they're all together centralized. There's no breaks between these links, right? Your IP link combines all of them together. And normally enterprises, data centers, universities, small enterprises, they all deploy their storage in this kind of environment. They make sure that you want to have cabinets available to house all these devices, and making sure that this is basically how you would store your information. Now, normally when you look at architectures in storage, your centralized storage is classified into a SANs, or it could be a fiber SAN or NAS storage, depending on how you look at this particular setup. But obviously, it's a simple deployment structure, so you can have a distributed coordination between multiple nodes. So this is what we're saying here about the spine and leaf. So you would have this kind of communication between the different connections, and that allows you to have a high failover. So you would have two network interface cards going there from two inputs from the server and so forth, and they would all maybe work together as one. So those are, your centralized storage scenario. The disadvantage, as you can see, obviously, there's isolated storage resources. If the IP link goes down, right? One of those links here goes down. You obviously have a problem, but you obviously have an uplink here. But I mean, that's obviously what could happen in a centralized storage scenario. Okay. And obviously, if you have to scale up, you have to add more disks and drives, and more connectors and so forth. So again, it becomes a kind of capacity expansion problem because you can create a bottleneck by doing it that way. Although already it's done that way because most people don't use a lot of resources. I mean, this is sufficient for a little enterprise that wants to run their things. So when you look at distributed storage now again, this is now a different way of how you look at it. So when you look at distributed storage, then we're looking at centralized storage, you have now multiple independent devices. So there are multiple independents, which means that you have a server one here, you have a server here, you have a server there, right? Same scenario as before. However, you have this whole virtualization volume layers now. So you have a volume here, volume 2, volume 3, and you can have more. And you also have your resource pools, which you have, resource pool 1, resource pool 2, and these are sitting on 6 hosts. So 6 hosts are running, by the way, this particular storage side. So it allows you to have multiple storage services to share the storage load. So this is not just previously we had only one storage controller here. Okay, we now have multiple here, as you can see here. And then also this improves then, your storage load, your scalability, also reliability and availability and efficiency. This allows you to handle more resources, and also give you a high performance. And financial systems would use this kind of setup in a distributed storage method. So distributed storage uses software to simulate all these functions. There's no hardware controllers. Yes, they are there, but you basically avoid the use of hardware controllers. You basically use your RAID software RAID to do this. So you would basically take the host, and you would basically combine them all together into one logical unit. So you could use RAID. We'll check the RAID differences now, but you could use, in this case here, they're all together. So this is like maybe RAID 5 because they all combine into different resource pools. And also this side here, you would also have a different RAID option here apply. Again, that allows you to have different volumes per resource pool, and all these resource pools all then, the server just use any resource pool available. So if something goes down, there's always backup. So they have this whole parity bit, which is basically error checking bits. That's also there. And when we get to storage basics, I think this is storage technology, but when we get to that, maybe that will be shown. I think it's probably still coming on the slides. Right, so those are ways of how you would use storage in a distributed storage. Now, it's not a distributed system, it's just a distributed storage scenario. Now, when we look at storage service types, I mentioned earlier there's only three. Cloud computing, there's only three storage types. You only have block storage, you only have file storage, and you only have object storage. What vendors normally do is they give them funny names, they give them weird acronyms, but it's their way, their flavor of how they want to be relevant to their particular service that they offer. And you saw in that previous slides that we did the server basics, over 250 services, but all the 250 services per vendor have only three different storage types. So you have block storage. Block storage is basically directly attached, to a particular scenario. It uses block storage, which means that it stores everything almost like in volumes in large disks, but can also lead to high cost and poor scalability because you have to scale So it's normally difficult to do that across networks. Your block storage is known for databases like Oracle, Oracle DBs, and so forth. So you can see Oracle and other databases would use block storage in this case. So here's your blocks. These are all volumes, and they all just store everything together. And then you have file storage. And file storage again is where your data is organized in a file mode. So, like I said, you can store any type of files here on this file systems, because that's how file storage work. And so you would have maybe a file sharing application you want to share with someone, then you would use file sharing. Okay, so my network was poor now. I hope I'm still here. And then your last one is object storage. Now, object storage is where you deal with in Windows they call it blob storage, Microsoft Azure, Amazon calls it S3 storage, Huawei I think calls it something, I'm not sure, maybe it's a different name, but I'm not sure. But these are your APIs or your REST that connects to your storage, to the cloud. But again, what you see here is basically object storage that's sitting there. It's closely connected to your block storage or your file system, but they store everything in key and metadata and so forth. So it's more like a way of how you can quickly access information and send it and create this whole archiving or backupping kind of thing. And those are different types of storage types that you get in storages. Common one we use is block storage and most probably file storage. And yeah, I think that they're all common. They're all being used, but it all depends on what use case scenario you use them for. So then you have RAID technologies, and also the RAID is the part that I showed you all the disk types. So now we get to the different types of disks that you get. So you have RAID 0, which I said earlier when I made an example of about 4 drives. So you combine all of them together. There's data stripping, and there's no parity, which means that there's no error checking, right? So what it means that you can combine to the largest storage you want to have. You combine all the drives together into one. You have RAID 1 here, then you basically mirror the drive. So there's no error checking, right? There's no parity. But what happens is that you can mirror your drives to have a clone copy of the other drive. Then you have RAID 3 again. Now you have stripping involved here. So we're stripping the data across the drives. And then there's a bit of error checking. Then you have RAID 5, most common one, also stripping the data. And now you added more parity, but it's now distributed, which means that it's on more of these drives spread. And 6 again is the same, but you have a double kind of error checking. And so what means is they just have placeholders for files so that if something goes wrong with the drive, that error checking can try to recover the file system in any case. So again, when you look at using two different RAID modes, if you have two different RAID modes on your server and you really want to use it, you can only combine 0 and 1. So you can create a 0 for more capacity and 1 to mirror. Or you can use it just RAID 10. Then it's similar to that, but it means that you can create two type of RAIDs, or RAID 5.0, which is a greater RAID 5 and a RAID 0 for improving performance. So that's just ways of how you can combine your drives. And this is basically what you would do. You would basically strip the data. And what we mean, sorry, disk stripping. What you mean by that is you take each space in the disk and you divide it into multiple strips. So not all the data is stored here. So you can see D0, that's here. It's being stripped into D0, D1 is there, D2 is there. So whatever gets stored into D1, it's on this drive, on this 2. Whatever stored in disk 3 on D2 is stored there. There's no copy of that there. So that's kind of how you strip the data. The disk, sorry. And then you basically have also I call it a, you don't have error checks here because this is just basically showing you how you strip into different locations and multiple disks. They're all part of one array. So it's one array, they're all together. So they give you, let's say this is 10 gigabyte, and that is 10 gigabyte, sorry, gigabyte, and that is 10 gigabyte. What happens is that they add all of this together. If you look at normal, and then you would have 30 gigabyte in total. So that will be your storage you have for all these three disks together. However, they are stripped in a way in that the information as it gets stored on the blocks, it gets stored to different disks in that sense. So again, it's basically just 3 disks stripped with 3 mounts of stripping. And that's basically what you do. You basically just create that kind of stripping. So your data really don't get stored all on disk one. It gets stored accordingly, performance of the disks and so forth. Right. Now, when we look at different ways of how you would do RAID, you would have mirroring, and mirror would basically create a mirror of the copies stored on each, and one would be like a redundant backup disk that you would mirror everything onto. So in this case here, this is now not a mirroring part, but mirror would be you would take this disk and clone it the same way as the other one, and then you would just have the other one as like a backup, a redundant disk. When you add parity check, like XOR checks, right? You would basically now want to see that if there's any, based on the blocks, you would basically now add error checking to it. So you basically use this almost like this logical operation, and this is normally where the server, the RAID, does this on its own. So it says one is true, the other one is false. So basically, it just creates that kind of checking, right? And that's basically normally for backups and that. So it goes through that, it stores copies on a redundant disk to improve reliability. And then basically, it uses the check algorithm to check if there's any additional information from the user data that stores, like, let's say it's a database, you store information files there. So it takes that, it calculates all of that, and then it uses that particular parity checks to make sure that the next disk knows about the previous disk. So it creates this extra disk. So that's why you lose space, because it creates this extra disk to make sure that it knows about these 2 disks, the XOR kind of scenario. So in this case, 1 is 0, 0 and 1 is 1, and 0 is always 0. That's the XOR algorithm or logic formula. And so again, that is basically how it does its check. So that's why you would lose space when you do error checking. But I mean, this is your part of making sure that your data is highly available. Right. Now, why we do that? Because you could have this scenario where, although this is a feature of RAID in this case, there's a hot spare. And so hot spare basically is if a RAID group is faulty. Let's say the RAID group is faulty, like this is the RAID group here. And so if it's faulty, there would be a backup disk, and this would be called a hot spare disk. And that will basically replace the faulty disk that's there. And in most cases, you would not set this up by means of any vendor has this set up in their RAID. This is Huawei's way of showing how they use their RAID model. Not all vendors have the same setup like this. Not all of them have a hot spare disk, and Huawei would probably have this as part of their software RAID. So you would have a hot spare disk. If this one goes down, you would have this one that just spins up and replace that one, in most cases, if there's a fault. And so that allows you to replace the faulty disk without having any break in your RAID system redundancy. Because remember, with RAID, you need to have that same amount of disk running. Otherwise, it's not working for RAID the way RAID operates. Again, there's a global space speed disk that's shared by all of them. That's how it's set up. Or you can make it dedicated based on a group on the system. And those are how you can reconstruct your RAID setup. Common RAID levels, here's the ones that I really wanted to get to. So your common RAID levels is the following. So you have RAID 0. And so you see RAID 0 here, you have a logical disk 1. But what you see here is that they've combined these two together, added that together, and then you have this logical disk here. So you have, if this was 10 and that was 10 gigabit, you would now have 20 here. That's kind of why we need to RAID 0. And you could do RAID 0 on your own PC, also your laptop. If you have enough drives, you could do that. And you can create that kind of logical block storage where all your data drives is to combine. Or let's say you have a PC, a server, and you have 4 disks, you can do a RAID all of them together, and you could have more capacity. Only problem is when one of the drives fail, and you have RAID 0, you're sitting with a problem that whatever was on that drive partially would be gone. Right. When we look at, so there's no fault tolerance involved in RAID 0. When we look at RAID 1, With RAID 1, you have a mirroring option now. So now you're going to mirror your drives, right? And so what you're doing is you're taking that drive, which could be 10 again, that drive could be 10 again, and now you're going to mirror. What you're doing here now is, it's a good thing to mirror, but you're obviously losing on storage. So you would just have a 10 logical unit because you kind of mirror them to have, half of each. So at the end of the day, the 10 becomes a 5, and that becomes a 5, and you end up with 10. So that's kind of when you mirror it. So that's basically RAID 1. You're just mirroring everything. You write everything to the primary disk and everything to the mirror disk. So you basically have, if there's something stored in D1, it's also stored on that side of the disk as well. And that's why we called it mirroring. When we look at RAID 5, most common drive, you would have more or less, you need to have probably a minimum of 6 drive for RAID 5 to work, kind of less than that. So you would have, parity that's added here, the disk, and another disk. So when you see here, you have your 4 disks here, but then you have these 2 that's added as part of checking. So they take storage on your, so they take a block storage basically for error checking. That's basically what they do. And that's basically just to make sure that, when you replace another drive or the RAID files, that error checking will just obviously check everything. That you have evenly distributed information amongst all the disks. That's basically what it does. And then the next one is RAID 10. And so RAID 10 again is where you have to combine the two. So now you have a bit of mirroring involved here. So you can see this drives here, these two were mirrored. So they RAID 1. This one is also mirrored, these two are also mirrored, and these two. So they're all mirrored in a way in that this one has a copy of that one, that one is a copy of that one, that one is a copy of that one, and that one has a copy of that one. And this is RAID 10. What it then does is it combines that two into kind of 4 logical disks. And then that basically gets combined again from RAID 0 to RAID 10, which is 1 logical disk. So you basically take 8 disks. So you have here 8 drives, or let's say disks, it's called the word disks, that you basically use here in order to create one logical disk, but basically 4 blocks of that, how it's combined together. So it basically combines mirroring, stripping all together, and then it basically, after the second level, it creates a RAID 0 to combine all of them together in storage. So you would have, for instance, let's say this is 2 terabyte, 2 terabyte, 2 terabyte. Let's make an example. 2 terabyte, 2 terabyte, 2 terabyte, right? Now you're going to do mirroring. What are you going to do now? You're mirroring that. So you would end up with 1, 1, 1, 1 because you're mirroring them. Then you would then combine that and you would have like a 4 logical unit because you're now doing RAID 0 here. You're adding that then again after you mirrored it, and then you would have like 4 terabyte. So from all your 2 terabytes that you had here, you would end up with 4 terabyte of the 8 disk. But you added error checking. You made sure that if something happens to the one disk, there's backup and so forth. So that's kind of how you look at RAID on that perspective, so that you really make sure that if something goes wrong with one disk, there's always backup. And most enterprise organizations need to do this in the data centers because they need to make sure that it's highly available. Otherwise, if the drive goes gone and your database on there, it can be the end of your career. That's what happens. So yeah. Right, so there you have another nice view of it again, how you look at it. But now this is basically RAID 6, which is double parity, so double ticking, right? So with RAID 6, you have your horizontal kind of XOR parity check across, which obviously uses RAID 4, but it adds another disk, which is this one here. It adds this disk also here, so it's double ticking. And so these two, it's taking a lot of storage from your drives. I understand that. And sometimes we don't want to lose out on storage. But at the end of the day, it's more about the benefit of the application, the database that we're going to run it on. We know that at least the database is highly available. It can handle all the load because all the data is spread across different drives, and we have this whole distributed storage working for us. So that's basically when you look at, RAID 6 double parity, which is basically making sure that your data is across. Now, let's look at Huawei's RAID 2.0. Huawei's RAID 2.0 is where you have, different ways of looking at it. So one, what they do is they use the enhanced RAID technology that involves reconstruction of the drive, and that is the backup disk, the hot swap. So if a data or disk is faulty, there's a reconstruction of that group, and it basically reconstructs it. So it creates a hot spare disk. That's Huawei's version. I'm not sure if any other vendor has that, so that's kind of what I'm just putting out there. Then they have RAID 2.0 Plus, which again looks at small resources, and then basically looking at the kilobits of the units all together working together. And then obviously what they do is they use this called virtual block technology. And then lastly, they have RAID 2.0 Plus again, Huawei RAID. So there's RAID 2.0 and Huawei RAID. This again uses your 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 new RAID technology, as they call it. And then they basically now evolve this 2.0 with a whole virtualization into a two-layer virtualization management. And I'll show you this next on the next slide. And so what they do is they're basically taking whatever's on the block on the for virtual disk, and they use 2.0 for a smart series improvement. So they would use SSD drives in order to handle the virtual resource pools and so forth. So they're kind of adding the two together, combining it, and then you have this kind of setup. So you have like your block, your SSD that runs the block storage. But again, what it does is it basically creates these little chunks of data, and it's spread evenly, on the drives, or let's say the SSDs. And then it basically uses that fine grained division of SSDs to evenly distribute the data to all the local logical units. And then each SSD can then balance the loads. So it basically creates this LUN, which is obviously the logical unit that you saw. But it basically takes all the SSD drives, create them into chunks, split them into chunks instead of blocks. And then that's how it does it. So it improves the SSD feature of how they use it in their data center. And this is wow, I think they call this NVM. I can't get to the name now, but I know that it has many advantages over RAID, especially when it comes to storages. I know CPUT bought this because I think on Huawei's website they post about it. So it's I can't get to the name now of the technology, but that is basically how they've used it. I think it's called Huawei. Uh, Ocean Store. Yeah, it's flash storage. They call it flash storage because it looks like flash storage. So it's Ocean Store, and then they basically use the flash storage system with all these, well, not SSDs. I think they use NVMe's. So this is still the older way, but I think now they have NVMe's that you can also use as part of that storage. All right, so there we have storage protocols again. Now we have back to SCSI. As I said, SCSI is, it stands for Small Computer System Interface. And it's there basically, to connect, your host and your drives, and all the buses and everything together, which is on the motherboard. It's there basically as a controller to make sure that things get sent to where it needs to go to, and that's basically what it's there for, right? It's not like the SCSI that we saw with SCSI controller that we spoke about now previously. It's basically just this whole SCSI interface that's there as part of how the arrays connect. So you have your array here, 0, you have a SCSI here, and they basically just have these bus connectors that how they connect these particular logic units here together. So you have these bus connections that communicate with each other on the whole SCSI layer. So they have their own kind of layer stack, how they communicate between the host, the server, and the disk storage on that end. Now you have iSCSI, which is more intelligent, or it's something added. So what iSCSI does, it added another layer between your physical layer, because you have a physical layer, your IP or TCP, and then you have now iSCSI. And so iSCSI again is basically that controller card, right? It sends these information, to the block data using TCP packets, but it uses encapsulation. So encapsulates everything over IP, the network, and then that's how it actually connects to the SAN. So that's how iSCSI works. So what it does is it basically just takes that information, adds that layer onto the packet, and then the packet is known that this is an iSCSI packet for the storage. So what will happen is that if it sees this particular layer, it will know that this needs to go to a storage technology like a SAN or a NAS, if that's the case, and not to a normal PC, right? So it will know where the packet needs to go to by adding that additional layer. So that was implemented by Cisco and IBM, and then all of the other vendors played a role in it, and they basically just allowed TCP to use that and send information quicker to the drives using that particular method by adding another layer on top, using the iSCSI protocol, so that it can actually allow this to happen much quicker, which you see here, because of the request that it gets sent to. Now, this is just another example to show you basically how it looks, what's the combination of it. So you have your link at the bottom. Remember, this is your layer one, your link layer. Um, Now I'm lying, layer two. Link is layer two. Your physical layer is the bottom. Then you have layer three here. You have layer four here, and then you have your iSCSI and so forth. So again, what you can see here basically is that on top of TCP, there's another layer added, iSCSI for the storages. And so what it does is it basically send information, and transfers it to the iSCSI layer, and then it generates that whole protocol data units or the PDUs, the packets, and send them to the right target over the network. So what will happen is that your switches and whoever sends the packets over across the switches and the routers, they'll know that this must go to that particular device because it's an iSCSI tag on top of the PDU. So again, what happens is that it receives the PDUs and sends it, via this to the layer, and then that interprets the whole what's called a CDB, which is a database, and then that allows it to send it to the devices quicker. And that's basically how they've added it. Okay, so you've learned, what fiber SAN is, right? You know what fiber channel SAN is, IP SAN, because those are all call it WAN kind of storage technologies because they're wide area. And obviously, when you look at if you have two sites, this is a discussion. If you have two sites and they all have different fiber channels like a FCN and a TCP, how will the storage devices of the two sites communicate with each other? Are you going to converge fiber channel and TCP to work together? Because you now need to consider the convergence part because you might have, for instance, this particular network here, that network there, this one would have, FC. Well, let's call this FC SAN, and then this one will have the IP SAN. So what will happen is that if they combine together, let's say they are actually supposed to be connected to each other. If you have this network and you have storage devices on between it, how are you going to converge these two to work together? So that's the question, basically, what discussion leads to. And so what you would do is you would then basically look at creating something like a IFC, something like that, or something like FC, fiber channel over Ethernet. So what you do is you take that Ethernet technology and you take the fiber channel technologies, and then you basically create something that they can coexist with each other because you don't want them to be separate from each other. Otherwise, you have to break your fiber SAN and then just create an IP SAN. So what they've done is they've created something called I don't know if it's called intelligent, but it's probably called a Internet Fiber Channel Protocol. And then they've also created a fiber channel over Ethernet. So that allows you to transmit your fiber channels over IP. That's one thing, one benefit of it. And then also what's it called, the Internet Fiber Channel Protocol is basically a gateway that provides the two together. So you would have this kind of setup, right? So you would have your fiber channel storage system here and another fiber channel storage system here. So this is your FC and another FC here. And so what you will do is you would have this gateway two gateways there that will allow you to connect via these gateways to your TCP, which is maybe your IP SAN network that's here. And that's basically how you would do, the connection between the two. Again, it's also if you have this kind of setup, because you need to think of converging the two traffic, IP over fiber, because fiber deals with light, fiber sends light, and obviously IP sends copper, with copper wire. So again, those are the scenarios you want to think about when it comes to network conversion, right? And it's very important. So they've done that kind of gateway, and that allows the services to implement the end-to-end connection with each other. So again, they've added another layer, which is called I think what's it called, Intelligent Fiber Channel Protocol. And so that layer again allows you also now to know where this needs to go to. And so if information comes from the fiber channel storage system, the gateway here will then add that layer and say that there's a header called this IFC that's added to the packet, that needs to go and converts over the network because that's added as another additional header. So again, those are how it uses the combination of the two together, so that the two can work hand in hand. So you don't have a separation between the network. So then you have fiber channel over Ethernet, and this is the part where it gets interesting, because now you have your normal fiber channel, but you've added something on top of it in order for your fiber to actually traverse to IP. So it allows you to actually send IP channel packets also. So what it does is basically it allows transmission of your LAN, your local area network, and your fiber channel network, your fiber SAN network, on the same Ethernet link. So it basically creates that whole thing. Maybe there's a conversion on the link you have to do physically, but it basically allows you to have a fiber channel connecting through, a local area network. That then reduces the number of devices and cables that you have to configure, or even power consumption, because you need to think about simplifying your management of your data center. So this again allows you to encapsulate your fiber channel data frames on layer 2 into Ethernet frames in layer 2. And that allows then the traffic to operate almost like it's the same, right? So that's the nice thing about this whole fiber channel. So it basically works on layer 2, and it allows that combination of the two to work hand in hand. So here's basically just an example of basically how the protocol gets encapsulated. So again, you have your physical layer here, you have your MAC layer 2, and you have your fiber channel on top of it. Now, because you're dealing with layer 2, this would mean your switches will have to be known about this configuration. So you basically then would send your Ethernet packets, combine them from the fiber channel, and then use this header here to make sure that they basically become part of the Ethernet protocol layer stack. So again, because the fiber channel stack has 5 layers, starting from 0 to 4, your Ethernet normally layer also have 5, but now we have these other 3 fiber channel protocol layers that's added on top of our normal. But now in this case, this is not normal, because remember on layer 2, you only go to layer 2 because you're dealing with a switch. So you only stop at layer 2, and then they just add another 3 layers on top in order to handle traffic. And that's basically how it handles the upper layer protocols when it comes to encapsulation. Encapsulates all of these together to basically create this, so that you can actually send that across using fiber to IP. So another discussion would be, what are the application scenarios of fiber channel over Ethernet? It could be when you obviously have a fiber channel network, SAN network, and you want to use your IP network, and you don't want to go break cables and change configuration. You would do that. And so you can think about how to apply it, but it all depends on the network, right? Are you going to use it for an Oracle database? Are you going to use it for a SAP system that you maybe have SAP ERP, or whatever, because you have to think of how you're going to use it as you apply it. So again, those are the scenarios you have to look at when you look at the fiber channel conversion. And if you need those protocols, it's there by default on this whole setup, because it uses this controller, which is the gateway, the Internet Fiber Channel Protocol gateway. And you can see that is probably a device specially designed to do this. You probably have to buy the device then. Right, so that ends our storage technology for today, and that ends our session for today, I think. Yeah, I think that will end today. Tomorrow we'll start at 9 again, but I think let's just do the quiz. So, which of the following statements about fiber channels, SAN, are true? So, we have to now think about what we just went through. So, we say that fiber channel switches are required. Are they required? Yes, because you're obviously dealing with fiber. So, yes, you need them. You don't need Ethernet switches, so that should be wrong because you're dealing with fibers SAN, FC SAN. Fiber channel links cannot be used between storage devices. I think that's wrong because you remember you can use your fiber channel links because that's how you connect to your storage devices. So that should be wrong. And then data packets commonly with fiber channel protocol stack comply, sorry. Data packets comply with fiber channel. Yes, that's correct. So because remember we saw that how you now basically add the packets, add the layers, and they have to comply with the fiber channel protocol stack. And then lastly, the performance of SATA disk is better than that of SAS disk. That's false. SAS is much faster than because remember SAS you deal with a SCSI controller, whereas with SATA you just have the whatever controller, RAID controller. So those are the topics of today, and so we've covered mainstream of data storage modes. We looked at network topologies. We looked at Huawei's RAID 2.0 block virtualization technology, which is using SSD. And we looked at how you can define and differentiate between centralized storage and distributed storage. And then also we looked at storage protocols, how they applied in the fiber channel area and IPscan. And next we're going to look at, so tomorrow we'll start with the nitty gritty, which is network basics. So tomorrow we'll do network basic, and you'll see really now where the network is so important with regards to all of the storage that we've covered, all the hardware we've covered, and all the software from the server side we've covered. Because these three technologies all have to work together in order to have your cloud or your data center working. So these are why I like this Huawei course, because it gives you the background of how things are working in a cloud environment where you don't really see it with some vendors. They don't tell you these things. And so I like the content of this because it gives you that perspective. So that is it from me for today. So what I'll do is I'll share the slides again with you, and I'll share the recording again. And so, is there any last questions? I'm going to stop the recording. But any questions you